Okay, everybody, this is the Drok constant voltage, constant current, 100 volt max. It's a step-up DC to DC converter, and it includes those functions which make it reasonable as a battery charger for lithium cells. It's basically a manual battery charger for cells in a pack, and you basically just use the equations for charging, which is 4.2 volts per cell. Right now I'm charging a 12 series pack made from Titan Flight RC modules. These are like 22 volt modules, 3500 milliamp hours, and these are your standard beloved Sanyo GA cells. Okay, so we are starting with an MFJ ham radio power supply. It is set at about 14 volts, which is like a lead acid charging voltage. Right now it's drawing 5 amps, and those 5 amps are going into a little Drok dealy bobber. So what we end up with, the setting for the lithium pack is 1 amp and about 48.5 volts. Now the 48.5 volts is just to kind of keep it on the safe side. There's nothing going on there. That's not some magical 90% charge. It's not a full charge. Okay, so the idea is to keep getting 1 amp coming through the Drok and into the lithium battery pack until this voltage rises to 48.5. Now if you wanted a full charge, it would be 12 times 4.2, which is I don't know, 50.4, something like that. Anyway, we're not going that high because I don't really like to fully charge these things, so I'm going to see what happens. It started out at about 46.5. It's up to 47.5. The voltage will gradually rise as the pack charges, and as I understand it, when you get to that final voltage, you allow the current to flow into the battery pack until it drops to something like 100 milliamps. So I'm not sure, I just got this thing. There may be a setting that actually shows the amps going into the battery. I can see if there's some way. No, it doesn't seem to want to change that. It doesn't seem to want to give me the amps. So, there we go. Yeah, okay, we're at 47.58 volts. And there's no way really of monitoring the amps, I guess, without another meter, which is no big deal. Just, grab one of these and put it in line. This is a watts up meter that would do the job. So pretend that was just put in line between the charger and the cells. Okay, that's it basically. I mean, there's a protocol for a full charge, which is 4.2 volts per cell, and you maintain that voltage until the amperage drops to like 10% or 15% of your charging amperage. So that's it. If you were hooked up to a solar, you would put the solar where that MFJ power supply is, and this would automatically adjust the voltage up to what you need for charging the pack. There's a provision in here which I don't really quite understand, You can set a parameter, an input voltage protection. So it says here, set the input voltage protection, and it seems to have something to do with solar charging, where your voltage might drop due to like clouds and stuff. So you might want to study this if you wanted a pure solar where you're just going to hook this up to a panel and you might have a cloud roll by and the voltage might drop. But I'd always run it through a battery. It's just the way my system is set up. So that's it for now. That's what I have.